Hello and welcome to our YouTube channel Chemistry with Tanvi. In previous lecture, we studied up to the point optical isomerism in halogen derivatives. In today's lecture, we start the chemical properties. Let us see first. That is laboratory test for haloalkanes. If we taking the alkyl halide treated with the OH from the either potassium hydroxide or the sodium hydroxide, then the alcohol is prepared and formation of halide ion. This halide ion is too much reactive species. Then when this Rx plus OH minus after heating gives rise to alcohol and X. When this reaction mixture is acidified by adding dilute nitric acid and the silver nitrate solution is added, a precipitate of silver halide is formed, which confirms the presence of halogen in the original organic compound. That means if the solution of silver nitrate, that is Ag plus aqueous solution, which acts upon this halide, which is also present in aqueous medium, then formation of precipitate. This downward arrow showing the precipitate silver halide solid is formed. That means this is the indication reaction of confirms the presence of halogen atom in an original compound. That is laboratory test. Here the next is nucleophilic substitution reaction of haloalkanes. Okay. When a group bonded to the carbon in a substrate is replaced by another group to get a product with no change in state of hybridization of carbon reaction is called as substitution reaction. We know that how many hybridization do you know about the carbon? sp, sp2, sp3. So here all single bond are present in a reactant side as well as in a product side. That means there is no change of hybridization state. Such type of reactions are known as substitution reaction. The CX bond in alkyl halide is a polar covalent bond. This bond CX bond is a polar covalent bond. It is positively polarized. In other words, CX carbon is an electrophilic center. This X is a negative charge, that means C becomes a positive charge. That means X is acts as a nucleophile and this carbon acts as this bond acts as a electrophilic center. It has alkyl halides react with the variety of nucleophiles to give the nucleophilic substitution reactions also. That means the reaction is represented general way as nucleophile, this Nu representation. This is our polar alkyl halide compound in which carbon is positive charge and X is partially negative charge. Then formation of this nucleophile replaces the hydrogen and the formation of product like this and X halide is given out. When a substrate reacts fast, it is said to be reactive. The reactivity of alkyl halides in a SN reaction depends upon the two factors, namely the substitution state, that is primary, secondary and tertiary of the carbon atom, and nature of halogen atom. The order of reactivity influenced by these two factors as shown in below. Okay, this tertiary alkyl halide reacts more faster than secondary alkyl halide than primary alkyl halide. This is our order. And halogen atom, nature of halogen atom, Ri is react faster than Rbr than RCl. Okay, very important point for the all competitive examination. Okay, let us see some examples of the nucleophilic substitution reaction of alkyl halide, in which alkyl halide when reacts with the reagent like NaOH or KOH in presence of heat gives rise to or the replacement of this halogen by OH, then formation of alcohol and NaX takes place. If we taking alkyl halide as a starting material and NaOR, sodium alkoxide, as a reagent. Each reagent carries either positive center and negative center. Na is a metal, so positive, and OR is a negative. So this in alkyl halide, X is a negative, R is a positive. So negative part replaces with the negative part. Then the formation of reaction or the product is R. This OR from the alkoxide of sodium and NaX, sodium halide, is given out. Okay, that means this ROR is a ether compound. Then in next, third, when alkyl halide is treated with the silver carboxylate, then formation of ester compound and AgX is precipitated out. So if we take the CH3Cl plus CH3CO O minus Ag plus and heat, then the formation of product is like this. This Cl and Ag is given as a side product AgX or AgCl, silver halide, and the formation of product is this CH3, then COOCH3. Okay, this is our ester compound, that is RCOOR. This is the simple representation of ester molecule. Then next is RX. When alkyl halide is treated with the ammonia, alcoholic ammonia, then in presence of heat and pressure, then formation of primary amines takes place with evolution of HX is another product. Then here also one of the hydrogen, this NH3 is split as NH2 and H. This NH2 is a negative charge, H is a positive charge. This X is replaces with this NH2 and the formation of product are NH2 and X from the alkyl halide and halogen from the ammonia is formed as a HX. Okay, then next reaction in when alkyl halide is treated with the potassium cyanide alcoholic in presence of heat, then formation of nitrile, that is alkyl cyanide compound, and RX. This is also important reaction asked for examination. Then next is when this alkyl halide is treated with the silver cyanide, which is also present in alcoholic state and heat, then formation of this RCN and AgX. This is precipitated out, known as isocyanide. Isocyanide में क्या होता है? This R is bonded to N triple bond C, not to the N C triple bond N. Okay, this is isocyanide structure. This is next is when alkyl halide is treated with the potassium nitride, then what happen? This K and X forms a product KX, and this remaining R O N double bond O, that is alkyl nitrite, is formed as a product. Then last reaction is when alkyl halide is treated with the silver nitride, then formation of the nitroalkane and AgX, silver halide, is precipitated out. Okay, these are some nucleophilic substitution reactions of alkyl halide. Let us see the mechanism of SN reaction. In that, first one is SN2. It is very important reaction for the point of examination. First, what is mean by SN? That is nucleophilic substitution reaction. First, definition. SN2, that means to represent the molecule, bi-molecule, two molecules involvement. So SN2 is a bimolecular nucleophilic substitution, is a nucleophilic substitution reaction where a nucleophile attacks an electrophilic center bonded to an leaving group, resulting in simultaneous substitution of the leaving group and the inversion of stereochemistry. This is the perfect definition of SN2 reaction. Let us see what happens in a reaction point. If we taking this methyl bromide as a alkyl halide, to which this OH nucleophile is attacked. Then what happens? This OH is replaces with the Br. Then formation of CH3OH, that is alcohol. Methyl alcohol is formed. And this bromide ion is in a product side. So the next is rate of reaction. Rate means what happen here, if we अगर इन रिएक्शन में क्या होता है, CH3Br और OH दोनों पे भी रिएक्शन का रेट डिपेंड रहेगा, क्योंकि अगर OH नहीं होगा तो रिप्लेसमेंट ब्रोमीन से नहीं होगी. सो फॉर दिस रेट इज इक्वल टू K, दैट इज इक्वेशन कांस्टेंट. रेट कांस्टेंट इज देयर, depend upon the concentration of CH3Br methyl bromide and the nucleophile OH minus. Then next, SN2 mechanism diagram. Here this is our CH3Br molecule on which the attack of OH minus ion takes place from the opposite side of Br, because Br is also bulky and OH is also bulky. Both the bulky groups not attack on a same side. So for pushing or removing this Br, OH should be attacked from always back side of the bromine atom. Then formation of this transition state is there, in which partial formation of this OH bond and partial breaking of this Br bond takes place, and these three hydrogen are as it is. Transition state always shown in a square bracket. Then it is suddenly falls into the product. Carbon in transition state, carbon is pentavalent. Pentavalent means 5 bond banata hai, 3 bonds with 3 hydrogen and 1 bond with OH and 1 bond with bromine atom. So in this transition state is pentavalent, it is so unstable, falls into the product like this OH, C, H3 and Br is remain out. So this is our SN2 mechanism. Then the silent features of SN2 mechanism. SN2 reaction proceeds via single concentrated step. It is a one step, single step reaction. Then inversion of stereochemistry. Walden inversion occurs at the electrophilic center. What is this? If this bromine is at present in a right hand side, then incoming nucleophile in a product always goes or present at the left hand side. So there is presence or the presence of inversion of stereochemistry. If स्टार्टिंग प्रोडक्ट हम R कन्फिगरेशन का लेंगे तो S बन जाएगा प्रोडक्ट में. अगर स्टार्टिंग प्रोडक्ट हमारा S कन्फिगरेशन का होगा तो प्रोडक्ट में हमें R कन्फिगरेशन मिलेगा. ओके, दैट मीन्स इट इज नोन एज इन्वर्जन ऑफ स्टेरियोकेमिस्ट्री. द नेक्स्ट फीचर इज फेवरेबल इन प्राइमरी एंड methyl substrate due to the minimal steric hindrance. This reaction always referred as or going with easiest with primary, then secondary and then tertiary substrate. Then next is the transition state involvement. Simultaneous interaction of nucleophile and leaving group is takes place. Both formation of bond and breaking of bond takes place in a simultaneously. And breaking of bond. Breaking of which bond takes place? CBr. And making of which bond takes place? COH. Okay, this takes place simultaneously. Okay, this is up to the SN2 reaction. Now let us see the another SN reaction, that is SN1 reaction. Okay, here the definition. SN1 is the unimolecular nucleophilic substitution, is a nucleophilic substitution reaction where a rate determining step RDS involves the dissociation of the leaving group from the carbocation intermediate followed by the nucleophilic attack. So the next is the rate. Rate is depends only upon what? If the rate determining step is there, that means presence of one step or two step reaction, it is a two step reaction. Let us first see the reaction. Here the tertiary butyl bromide compound is there. Tertiary butyl bromide. this OH is a nucleophile which attacks on this carbon atom. Then formation of this tertiary butyl alcohol Pr- is evolved. Then let's see the rate mechanism. Rate is directly proportional to the only first, that is CH3 tertiary butyl bromide. Why not OH? Because this tertiary butyl bromide starting material is very much unstable compound. Why it is unstable? Because it is very sterically crowded system. In sterically crowded system, removal of or breaking of CBr bond takes place very fast. Then formation of this carbocation. Then in next step, attack of this OH minus takes place on this carbon atom and formation of product takes place. So let us see. In first step, what happened? This CBr bond is break. This is slow step. Slow step is known as always rate determining step. Then formation of this carbocation intermediate is formed. This carbon containing 3 CH3 group arranged in a triangular planar manner, and this Br minus is as this side. Then in second step, what happened? This carbocation molecule is there. Attack of this nucleophile takes place from any side because this is triangular planar carbocation. So each side is feasible for attack of nucleophile. Okay. Then formation of product takes place, that is alcohol CH3 3 times of carbon and OH. This is our product. Okay. Then this product tertiary butyl alcohol is obtained. What is the silent features of SN2 mechanism? First, SN1 mechanism. SN1 reaction proceed via 2 steps. It is a 2-step process involving the formation of carbocation intermediate and attack of nucleophile on carbocation. This is second step. Then the reaction rate is independent on nucleophile concentration. very important point. इस रिएक्शन का रेट न्यूक्लियोफाइल के concentration पे डिपेंड नहीं रहता क्योंकि रिएक्शन starts with the formation of carbocation. The next is carbocation stability influence the rate of reaction and the product distribution. It is also simple point. Then next is SN1 reactions are favored in tertiary substrate due to the stabilization of carbocation. Tertiary substrate, then secondary, then primary. This is the order of reactivity towards the SN1 reaction. It is also important point. Then next, let us see the difference between the SN1 and SN2 reaction. Okay, first full name. SN1, that means unimolecular nucleophilic substitution reaction. In SN2, bimolecular nucleophilic substitution reaction. Rate law in SN1 depends upon only on a substrate. Here the rate depends upon substrate and nucleophile, concentration of substrate as well as nucleophile. Then reaction order. In SN1 it is a first order reaction. In SN2 it is second order. That means how much molecules are involved in a reaction tells the order of reaction. Then next is the mechanism. SN1 reaction is a 2-step mechanism, formation of carbocation intermediate and attack of nucleophile. And here SN2 is a 1-step mechanism, simultaneously bond breaking and making in a step. Then next is the intermediate. Here in SN1 carbocation is an intermediate, in SN2 there is no intermediate. Here stereochemistry. Racemization. Here attack of all sides are possible. That means attack all sides are possible. That means both D and L configurations are obtained. So here racemization. D and L means racemic mixture is obtained, and in SN2 there is inversion of configuration because both nucleophile and leaving group are bulky groups. Then next is substrate preferences. Here SN1 reaction goes good with the tertiary, then secondary, then primary and methyl substances. And here SN2 reaction goes with the methyl, primary, secondary and then tertiary substrate. Then nucleophile. Here the nucleophile, generally in SN1 weak nucleophile is sufficient, and for SN2 requires strong nucleophile. The next is solvent. For SN1 reaction is polar protic, that is water or alcohols, and for SN2 polar aprotic solvent like acetone and dimethyl sulfoxide, DMSO. Here the example of solvents: water, ethanol, methanol in for SN1 reaction, and acetone, DMSO and DMF for SN2 reaction. Then temperature effect, generally favored with the high temperature in SN1 and generally can occur at lower temperature in SN2 reaction. Then rearrangement. What is mean that possible? Here in SN1 rearrangement is possible because of triangular shape carbocation is present, and here rearrangement are not possible. Then leaving group nature, in SN1 is a good leaving group is necessary, in SN2 good leaving group is also necessary. Both are the same. The next example of leaving groups: halide, Cl minus, bromine minus, I minus, tosylate, etc. Here also halide, Cl, bromine, I minus and tosylate. Example of reaction: tertiary butyl bromide in water, and here methyl butyl bromide in NaOH or acetone. Okay. Thank you for watching. If you enjoyed this video and found it helpful, please give it a thumbs up, leave a comment and subscribe too. Don't forget to hit bell icon to stay updated over our latest videos. See you next time. Bye bye.